So today we are going to discuss an important but difficult kind of concept in the quadratic equation chapter in class 10th mathematics. Okay, so the topic as such will be nature of roots in a quadratic equation. So as we all know, quadratic equation will give you two roots. It always has two solutions. Okay, so we are going to analyze that what is the nature of the roots that is going to be there. So if you have a quadratic equation, there will be two roots or two solutions. So what will be the nature of those two solutions that we will get? So it is not necessary for you to solve the quadratic equation to know the nature of roots. In fact, this is one of the questions in your ICSE examination, to find out the nature of the roots without actually solving the quadratic equation. Okay, so we will begin with a few examples, okay, because those are the best ones to understand. So let us take the first example. Before the first example, we will first analyze the general form. Okay, so the general form of any quadratic equation, will be ax square plus bx plus c is equal to 0, where we all know that a cannot be 0, because the moment a becomes 0, then 0 into x square will make this term disappear, and therefore you will be left with only bx plus c, which will then become a linear equation. Okay, so we all as mathematics students, we all know that this is the general form of the quadratic equation, in which b and c can become 0, but a should never be 0, because you have to have a x square term, because x is your variable in this equation. Therefore you need to always have the x square term present in the equation. So next question that comes up is that if this is the quadratic equation, now I'll erase this portion, that is understood. So if this is my quadratic equation, then what will be my solution? Certainly there will be two solutions. So Sridharacharya gave us this particular formula: x is equal to minus b plus minus under root b square minus 4ac. Please note that this entire b square minus 4ac is in the under root sign, or under the under root sign, upon 2 times a. Okay, so that is the equation. Now certainly this must be looking a little complex, but you all know that if we actually have an equation with a, b, c values given, then we can put the a, b, c values and you can actually get x values. Okay, now how will this x value be 2 in number? Because we keep saying that quadratic equation will have two roots. So one root you will get when you use the plus sign, and the other root you will get when you use the minus sign. Okay, so that is the criteria. Now the bracketed portion, which is in the under root sign, please note that is known as discriminant. Okay, so that is known as discriminant, and it is represented with capital D, and certainly the formula is b square minus 4ac. Okay, so we are going to call this bracketed portion as discriminant, because this discriminant study is going to actually help us in finding out the nature of the roots of any quadratic equation. Okay, so for the time being, we will remember the Sridharacharya formula, and we will remember that the bracketed portion in the under root sign in the Sridharacharya formula is known as the discriminant. Okay, so it is this discriminant that we will use to find out the nature of the roots in any given quadratic equation. Okay, so now let us move ahead and take some examples. Okay, so while we take examples, I will keep this discriminant written over here. So we have d is equal to b square minus 4ac. That is my discriminant formula. Okay, and my roots, I will have this root also written, minus b plus root b square minus 4ac upon 2a. Okay, so this is my first root, let me call that as x1, and my second root will be minus b minus under root b square minus 4ac upon 2a. Okay, so the two roots that we will get for any equation will have this formula. So I have actually segregated the plus and minus formula and kept them separately. Now, keeping this at the back of our minds, we will start with the first example. So let us have an equation. Let's say x square minus x plus 1 is equal to 0. Okay, so this is my quadratic equation, and again the question is find out the nature of the roots without actually solving this equation. If you want, you can solve this equation and then you can get to know the nature of the roots, but we will use, remember, the discriminant formula for that. Okay, so what is my standard equation? My standard equation is going to be always this, as we just now discussed. So the first step will be to compare. Okay, so what will be my a value? If you compare this term and this term, they are like terms. So the coefficient of x square here is 1. The coefficient of x square is a. So a becomes 1. Okay. Similarly, when you compare this term with this term, you will get value of b as minus 1. And similarly, when you compare the constant terms, you will see that c is coming out to be 1. So once we have noted down all a, b, c values, then what we will do is we will then make use of this discriminant. So discriminant value, the formula is b square minus 4ac. So I will now put the values. B value is minus 1, so minus 1 whole square minus 4 times a, which is 1, into c, which is also 1. So I get this, which will then result in minus 1 whole square, you know that it is plus 1, minus 4 into 1 is 4, which gives you a minus 3. Okay, which is a negative number. Now you please note, children, that once we have got this d value, now this d value has come out to be minus 3. And please remember, children, d value is nothing but the portion which is in the under root sign. In fact, we are calling b square minus 4ac as d. So if you get a negative number like you have got here in the under root sign, what will your answer look like? So let us write this over here. Let's say that we have my first root x1 is equal to minus b. Now what was my b value? My b value was minus 1. So minus of minus 1 is going to give me plus under root. Now there is no need to write b square minus 4ac because you have actually got the value of that. So that is minus 3 whole upon 2 times a. A is 1, so 2 into 1 makes it 2. Now similarly, the second root will be 1 minus under root minus 3 upon 2, because essentially the formula is same, only plus will become minus in the second root. So now you see, children, as long as you have the square root of a negative number, this is always going to give you the imaginary portion. Okay, you are always going to get an imaginary portion. In fact, in complex numbers, you actually do study the imaginary numbers where you have that iota form. Okay, so can you now guess what could be the nature of the roots? Are these roots real? Certainly not. They are imaginary. Okay, so we will write roots are imaginary. Okay, roots are imaginary. Now please note, children, that you really did not have to calculate these roots as such to know the nature of the roots. Why? Because the moment you find out discriminant value and it comes out to be negative, you will simply say that roots are imaginary. The reason why I took out the solutions is to help you explain how this minus sign is creating imaginary roots, because under root of a negative number is imaginary. Okay, so the moment you get d as minus number, as a negative number, you will straight away say roots are imaginary without solving this portion. So this portion will not have to be solved. Okay, so essentially this is your part of your solution. Okay, so this is a case where roots are imaginary. Now we will pick up a case where roots will not be imaginary, so they will be real. Okay, so let us take up an example again. So the next example would be, I'll just make a small change here. So let's say, for example, x square minus 2x plus 1 is equal to 0 is the example that I want to take. Again, the question will be, determine the nature of the roots of this quadratic equation without solving the equation. Okay, so my general form, once again, I will write one below the other. Make sure that you have like terms written one below the other. Okay, like this. So again, you will compare. Your a value will be again 1, b value this time will become minus of 2, and c value will become 1. Okay, so using these values I can calculate my discriminant. So discriminant formula again is b square minus 4ac. So I will use b value as minus 2 whole square minus 4 times a into c. So I am this time going to get, please note children, minus 2 whole square will be plus 4, and this will give you minus 4. So 4 minus 4 becomes 0. So this time my discriminant value has come out to be 0. Children, please note, in the first example d was negative. Here d is 0. In the third case we will discuss d positive. Okay, so what happens if d becomes 0? So let us go to our Sridharacharya formula again. It was minus b plus minus under root b square minus 4ac upon 2 times a. Now you imagine children, this bracketed portion in the under root sign is d. So my d value has come out to be 0. So this entire thing is 0. So square root of 0 is 0. So what is happening because of that is that my roots, individual roots, will become equal. Let's see, minus of b is minus 2 already, so minus of minus 2 will give me plus 2, and there is no need to write plus minus 0 because this whole portion has become 0. So plus minus 0 is nothing. I mean, it is not going to change any value. So 2 upon 2 times a is 1, so 2 into 1 makes it 2. Okay, so once you do plus 0 upon 2, and then the next case x2 will be 2 minus 0 upon 2. The reason why I am showing you this separately is so that you understand that plus 0 and minus 0 is going to have no effect on the answer. In fact, your answer, both x1 as well as x2, will come out to be 1. You see, 2 upon 2 is also 1. Here also 2 upon 2 is 1. So in fact here, what is the nature of the root here? Roots are real and equal. You see, here we keep saying that there will always be 2 roots, but the answer is coming out to be 1 only. It is because both the roots are 1 each. Okay, so roots are real. Naturally 1 is a real number, so roots are real and equal. Okay, so whenever d is 0, your roots, nature of the roots will be real and equal. Okay. Okay, so now we will go on to the more difficult aspect of it. So we have discussed d negative, we have discussed d equal to 0. So when d is negative, you have imaginary roots. When d is 0, you have real and equal roots. Now we will have a look at d having positive values. Remember, d is the portion in the under root sign of the Sridharacharya formula. So let us quickly compare this again. So you always will have to compare with the standard equation. Okay, so my a value becomes 1, b value becomes 5, c value becomes minus 1. You just keep comparing. Okay, like terms. Okay, so this is what I have got, which gives me my d value as b square minus 4ac being the formula. So I'll now put the values. B is 5, so 5 square will become 25 minus 4 times a into C. So C is minus 1. Okay, reason why I'm writing this in bracket is because minus and minus will get multiplied to become 1, to become plus. Okay, so D is equal to 5 square is 25, minus and minus becomes plus, 4 into 1 into 1 is naturally 4. So you get a D value which is 29, and as you can see children, this time D is plus. Okay, D is plus. Now again, let us look at the Sridharacharya formula. Minus b plus minus under root b square minus 4ac whole upon 2 times a. That is our formula. This bracketed portion in the under root sign is my d. So now you can see that d has come out to be 29, which is a positive number, but it is not a perfect square. Okay, please note here children, this is the important aspect. So x1, let me write x1 will be minus of b. B is 5, so I will write minus of 5 plus. So I'm going to use plus sign because this is the first root. Under root b square minus 4ac has come out to be 29. So I'm going to write 29 upon 2 times a. So that is 2. Similarly, my x2 will be exactly same but with a change in sign here. So you will have this. Okay. Now children, again as I said, there is no need for you to actually put the values here and calculate the 2 roots to know the nature. Reason why I am doing this here is so that first you understand how we get a particular nature of a root when d is positive and d is negative. Once you understand this, then you will immediately learn, keep this in your mind, that whenever d is positive, what is the nature? You keep that in mind and you will simply write. So your solution will only involve this step, this first step, comparison, then calculation of the discriminant value, and based on how much it is coming, whether it is positive, negative or 0, you will simply comment about the nature of the root. There is no need to solve the roots. So now let us come back to why we are solving, to understand. So 29 is not a perfect square. So square root of a non-perfect square number is going to be irrational. Okay, so if you use your calculator to find out a square root of 29, or you sit down to do it yourself, you will find that it will continue to be going on and on in decimals. Okay, so it will not be a terminating decimal. Okay, so it will keep on and it will not repeat also. Okay, so in fact if you find out, it will be something like 5.8389556 and so on. Okay, so first question now is whether the roots are real or not. Yes, the roots are real because there is no negative number in the under root sign. So roots are real, but are they equal? No, they are unequal. Why? Because once you will do a plus, once you will do a minus, so you will naturally get different numbers. So real, unequal, and now these 2 parts were easy to understand. The last part will be whether it is rational or irrational. So here it will be irrational because the portion in the under root sign is not a perfect square, so it gives you an irrational number in return. Okay, whereas had this number, now I'll make a small change in this value to help you understand when the roots can be real, unequal and rational. Okay, so suppose that you had got a value instead of 29, you would have got a value 20, let's say 16. Okay, suppose you had got a value 16 here in the under root sign. Naturally you can have different values of a, b and c. So sometimes you may get a perfect square in the under root sign, which will give you an exact number. So root 16 will be 4. Okay, so once you will have minus 5 plus 4 upon 2, and then you will have minus 5 minus 4 upon 2, which will give you exact rational numbers. Okay, so in that case your answer, let's suppose that if this was the change, then your answer will become real, unequal and rational. Okay, so now the nature of the root becomes rational. Okay, so please note children that when d is positive, then there are 2 cases that arise. One will be a rational case if this number is a perfect square, and it will be irrational if this portion is not a perfect square. Okay, so this is the difficult portion to understand, or rather it needs a little practice, but I am sure that this is the entire crux of the matter. You should be able to easily solve all the questions on the nature of roots if you have understood especially this third part of this lecture. Okay, so for finding out, determining the nature of the roots, the important thing is D, which is discriminant, and it is the nothing but the portion in the under root sign. So once you calculate that, based on that, it can be either negative or 0 or positive. So if it is negative, straight away write imaginary roots. If it is 0, you will write real and equal roots. If it is positive, then you will first look at that number. If it is a non-perfect square, then the roots become irrational, and if it is a perfect square like we had 16 here, then you will have a rational nature of the roots. Naturally, in both cases it will be real and unequal. Okay, so thank you.